Oh, hi. How are you? Yeah, I'm super happy to be here at the Boston GodotCon. I hope you all had safe travels to here. I'm Adam Scott. I'm the web team lead from. I'm working for the Godot Foundation, but I'm already like way ahead of my slides. So who am I? I'm. I'm not really I'm not really Adam Scott, but I am. So I'll begin. So I'm hi. I'm Adam Scott. You might remember me from the Doom talk at the GodotCon Munich, where the audio for the live streaming was really bad. I am the first talk of the day, so and from of the con, so I really hope that the sound will sound better now. But it's not live streamed, so I think everything will be all right. So who am I? I'm the lead web maintainer from Godot and a full-time contractor for the Godot Foundation. So I can live from your donations. So I cannot be understate how grateful I am for your donations, for you being here today. And I hope that my what I'm doing at the Godot Foundation like lives up to your donations. My background, I have relative like to the web platform. I have two great backgrounds. So I have one in based on Flash and the other on HTML5. So I think I'm quite apt to talk about like what is the web platform. So what it leads to the next slide. What is the web platform? To begin understanding what is the web platform, we need to know what is the web, like conceptually. So it's essentially four technologies. First, there's HTTP. The second one is HTML. There's JavaScript and there's CSS. Yes, there's more technologies than that, but like these are the core of the current like modern way that we experience the web. So I will teach you like a little bit how it works. I think that the web is like the universal, like the browsers are the universal virtual machine because like from anywhere you are, like you are using a phone, you're using a desktop computer, using like smart technology and such, you're using like the same interface and such, so it's really great. So imagine that you're in internet cafe and you need an internet cafe and you need to like to require something from a website. So you'll ask the server to get you like the content of what the server can give you. So it will answer you back an HTML file. So that HTML file is pretty much like a recipe for your browser to display something on your screen. So we begin with the first tag that is HTML. We say that this file is HTML. So in the head, we can say like, oh, what's the title of my web page? And here's like what's important, like here's my style. So when the web page, the HTML file will point like towards like, hey, like for that page, you'll see that there's some style. You'll find that file there. So the title, the link. So the body is the content of your website. So there's a title, there's a paragraph, and an image. So the website tells like the server tells like in that totally rad file, you'll find an image and you can display it there. You can add some actions and such. You can add some script, and that's pretty much it. So then what you can do is that your browser will ask for these files, will ask for these script, these style sheets, and the server will answer you back, and that's where the virtual machine comes from, is that it will parse everything and show you the result of what essentially the HTML file tells the browser to do. So let's talk what we are here for, like gaming on the web platform. First, we'll talk about like a little history of the games of gaming on the web. I want to talk to you about this because it's really important to know where we're coming from before like talking about where we're going to. So first of all, there were HTML-based games. There was a great source. It's the HTML. I think I'll render public my slides. So there's a great source on. It's a paper, a scientific paper on like the history of web games. There's this one. It's called CyberMud. It's an interactive fiction driven by hyperlinks. So it was the really bare minimum HTML when it was invented. It was really about hyperlinks and like the links that you can click and get to other pages and get other from servers, get other HTML pages and so on and so on. So you could like read the text and like go like make some actions based on the URL you were the links you were clicking on. Then after that, there was Java applets. So Java applets is like you install Java on your desktop computer, and then the browser could like say the HTML file. You could say like, "Hey, can you open up this file in Java, please?" And then Java will open up in your browser, and you could like play like backgammon. It was super like next step of technology, like but like it was something that you could do first, but like that was really early on Java. But like there was this little game that was made like a little bit after that used Java. I think you may know about it. It's called RuneScape. It was a really popular one, and you could play in your browser. You would open up RuneScape.com, and you play RuneScape in your browser directly. So, and it was using Java also. And there was another game, and it was made way later. You may know it, and it was made in Java, and it was playable on the browser. It's a little game called Minecraft. So there was for the older ones, there was Shockwave. That was a one of the earlier ways to play games on the internet. That one was the first game that Shockwave like was released for Shockwave. It was Toy Story on the website. So Toy Story, I think it was released in 1995 or something like that. So really, really early in the internet age. And yeah, Shockwave was made for usually for was made for like interactive CDs and such. But like you could put it in your web page and it could show up. But again, you had to install Shockwave first. Oh wait, yeah. Help me find this game, please. It's like, oh no, the image it doesn't show, but like it was like I did some drawing, but like, it doesn't show. So I'll ask you personally if you know the game I was talking about. It's so bad because like it was a super opportunity to discover like, but like yeah, it happens. Then the rise of Flash Player. I think like it's something that was ubiquitous in the web, like for a while. So Flash was really like something. It permitted like to do some permitted to do like video before HTML was able to do video by itself. So YouTube was based really like you if you wanted to watch YouTube videos, you needed the Flash player. It was something you could like create animations. It was really a gateway to all like video game creators to be able like cheaply create video games that could be shared online with people. Maybe some of you know this website, Newgrounds. Like it was really like a portal, but like it's literally a portal, but like a portal to community-based like games. Like you could like team up with people and like publish your game. I used to like put a lot of time on Newgrounds. There was Miniclip too that had a lot of games. So the screenshots I got was from the web archive. That's why Ruffle tried to load, but I can it wasn't able to. So yeah. So does anybody feeling old yet? Yeah, there's a lot of hands. So just to show you how the what Flash was, I will show you like a little bit of Metal Gear or some. If you know Egger Raptor from Game Grumps, it's his first Flash. Like it was first, maybe not first like animation, but like what made him like put it on a map, put him on a map. So maybe I'll try. I hope that it will work. I'll put some sound. It's not super safe for work, but like we'll endure. Oh, it doesn't show. Oh, it doesn't show. Okay, sorry. It shows on my. Oh, okay, I understand why. Okay, do this. It's here. Yeah. Okay. I'm sorry. I played it on my presenter side, but I didn't play on the. So yeah, let's play. Oh, it doesn't work. Okay. Well, that was Metal Gear Awesome. Really something to behold. Next, I want to show you like a another game that's Fancy Pants Adventure. It will be difficult. Maybe I can like put the mic here, but like, yeah, I'll not able to. I'll not be able to like play and hold up the mic, so I'll just put the mic there if I can. Nope. Well, whatever. I'll try to. I give up. So if I do this, oh yeah, I can jump, I can run. So I can go here. So start game. So it was you were really able to like create some great experiences with Flash. So games on the web, like you can, you, yeah, you could do a jump is yeah. So you could do some flips. So that's Fancy Pets Adventure. That was a great game. I think we by the reaction of the crowd, I think we were a lot to play Fancy Pants Adventure. So yeah, that's great. So but unfortunately, Flash wasn't the most secure software. So there was a lot of bug reported for Flash and vulnerabilities. And the nature of the vulnerabilities was that what you install Flash like besides your computer, like besides your browser, and technically, if you add the opportunity to not hack but like get into Flash, you had access to the rest of the computer. So that was kind of dangerous to like load the Flash game, and maybe it could be vulnerable to some attacks and such. So yeah, like security wise, and you were running like Windows XP, so it wasn't like the greatest like environment to be. Well, you had to have a virus detector or something like that. So yes, antivirus. So yeah, so Flash wasn't super secure, and there was their fault. So Flash the dinosaur was extinct by Steve Jobs and his iPhone. So yeah, the iPhone pretty much like ended the Flash dominance because what happened was that Steve Jobs like famously said that he didn't want Flash on his platform because it was like you had to install it and it was a plugin. So maybe like security wise, it wasn't the most secure software, but it drained batteries. Like it was hungry. Like Flash was not the most optimized platform. Well, it could do a lot, but like yeah, it required like some juice. And iPhones at the time didn't weren't the iPhones today. So yeah. Some tried to capitalize on the iPhone's commitment against running Flash. So there was the Motorola Droid. It was my first smartphone because like it supported Flash and well, it's Motorola Droid is the US name. It's Motorola Milestone elsewhere, and yeah, it was advertised to have Flash 10.1 support, and yeah, it run like crap. And I could show you like that's a real video from Adobe itself. Oh no, it's the wrong again, same error. Go here, play. Suspect. Okay, and if I put the video there, I think there's an example of like they're like, oh, like one of the things we like is like there was like some bunnies that recreated films, so it's even before like YouTube and such. There was no YouTube, so you had to like use vector art and such directly to play, and you can see even in the video. Oh, it's like you know that the animation maybe is shaky a little bit and not very like optimized and such, but like you see that the phone seems to struggle like to be able to render everything. So not great, not great. So I'll just. So yeah, the iPhone and mobile games were a great, great, great hit, and there was that little game called Angry Birds, and you may know like it's a review, it's a real review like 15 years ago on YouTube, and they show like how you can show like you can see how like the interface of the iPhone store and such it was something at the time, but like it's 15 years ago. Yeah, you can guess. So yeah, but there was some controversy with Angry Birds because some told that it was like a ripoff of a Flash game called Crash the Castle. So it was, I think, Armor Games published game, and you essentially like needed to crush a castle with a catapult, so a trebuchet. So you clicked on to swing the bar, and like you clicked again to release the rock. So based on the physics. So it was physics based, really novel in Flash and such. So yeah. I played this game also a lot. So I saw the similarity between the games and such when it came out. So I think I'm okay on the time. That's nice. So the W3C decided to play catch up, like because the iPhone betted on like web experience and to be able to like there was this issue with the web with Flash, and there was a lot of like interactivity. There was a lot of websites that used like interactivity and Flash, but like there was a lot of like on over do this, but like with an iPhone and your thumb, like your thumb or like your finger, like you can't over something. So a lot of websites didn't work on iPhone. Like if even if like there was like even if there was like Flash support, a lot of things would have been broken on iPhone. So there was a time. So it was the time that when the iPhone came out, HTML5 began also, but like it really paved the way to like more technologies on the web. But there was a lot to do like in 2020 in 27 2007. So what is the web platform for games today? So web technologies have grown a lot since 27. Like there's now like a lot of technologies that you're able to like just summon with your browser, like your JavaScript code. You can like access a lot of good things on the web. So the web used to rely on third-party plugins to add interactivity, and I really want to emphasize on that because like Unity, when Unity started, like they started pretty much essentially like on the basis that you could run 3D games on the web. It was like a Unity player to installed, and you could like play. It was Jetpack Brachiosaurus. Sorry, the dinosaur like with the long neck. So you could like play like a really nice 3D game with physics and such like on your browser. It was like revolutionary. It didn't look like RuneScape. Like it looked good. Uh, so that was pretty nice. And yesterday, like, it's a really nice tidbit. Yesterday, I talked with Ariel Mansour, like, he's the co-founder of Godot, and he told us that actually Godot had a plugin like that when way back, and not only that, but like they did that plugin because they were like making sales pitch to like people, and like people were like, can you do like 3D on the web? And they were like, well, you cannot like do something for the web yet. And they went for Unity. So like even then, like there was like this competition between Unity and Godot. But like yeah, so there was the plugin for Godot, and this paved the fact that they did the plugin for Godot. This paved the way. The technologies that they implemented for this paved the way for the mobile ports of Godot afterwards. So like your mobile games and such, like literally have like insta story, like code wise and such, from the native plugin of Godot. So that's something that I didn't plan to add into my talk, but like that's really nice to know. But like, yeah, like again, like I said for Flash, like this introduces a lot of vulnerability, because if you attack the plugin, you can leak through the system. And this is something that like you need to not only trust the content that you download, but you need to trust the plugin provider itself. So a lot of like third parties to trust and such. So it was decided that the web needed to implement a lot of public and safe APIs so that the browsers themselves could handle a lot of things that the plugins could handle before. So they introduced like a lot of stuff. You can have like I will not like talk about everything, but like there's like history, like you can like create and change the URLs, and when you press back, like you can go to somewhere like really that is important, and not like some temporary page that you landed on. Like you can like store, use local storage to store like actually the game. Like you can, once you download it, instead of like re-downloading each time you visit the website, you can actually like rely on the cache to make it the game load instantly. There's WebRTC, WebSocket, Web Transport that is coming, that permits you to like do some online multiplayer, like online capabilities to the web. Web animations, web audio, like Canvas, really, really, really important. WebGL, WebGPU, WebXR, really nice things that we can do, that in the web can really let you like do a lot of things that maybe we can consider it granted like on desktop, but like now you can do it on the web. What's the potential of the platform? So as I told, like I didn't tell it, but like in my head, I already told it myself. But so in the web, there's no formal installation, and that's a great, great, great thing. Like imagine about like WebJam and such. Like you create a game for the WebJam, and then you made it available like on your itch, and that makes it so that your users and the players don't have to actually like download and install a file and double click on the executable and like have a file to handle afterwards. Like they just can play your game inside a web page. That changes a lot. And for like and for mobile also, like your mobile users, like they are more and more like happy to like be able to play games, like real concrete games that looks good and that look good, but like without having to go to the app store that is bloated, and there's a lot of things there and that you need to like install and pay or something like that. You just have to go to the page and then play the game. It really is like streamlines like a lot the experience. And yeah, as I said, we can store the game temporarily on the device. So there's a big limitation for the platform on the web, and I want to talk about it now so that you know about this. But it's really one of the like biggest limitations, but like it's not something that it's something that you can overcome, but it's single threaded due to security mitigations. So yeah, do you know about these vulnerabilities? These are side channel attacks discovered in 2017. What's the gist of it is that the vulnerability is in the hardware design of our current CPUs, and it's not software based. So either, oh, so whether you are Windows, Linux, Mac OS, or sorry, so or you updated your drivers or something like that, it's really about timing and the way that CPU caches memory. So CPUs like just to explain rapidly like how these security vulnerabilities work is that your CPU actually, when they run your conditions, even in C, like when they run your condition, they load data into the cache. And like their local cache, like the CPU cache that is like quite small, but like, so they load data there and they access it, and how fast they can check, a third party could like look into it and like be able to like know if the data that is like the offset in memory of the data, like due just to the fact that it answers back more rapidly than if it was not cached, it can detect that that memory was in the CPU, so it can read it, and then it knows that the data was just like worked on. So yeah, it affects everyone, and operating systems were patched, and like some programs like were most of the programs were slowed down because of this. And the way that they did in the browsers to mitigate this issue is to limit the use of shared array buffers. The shared array buffers are like memory that you can store in the web browser, and that they can be accessed by workers, so like threads, like the equivalent of threads in the web. So you can like really, without shared array buffers, you cannot like really like share work and make use of these threads. Like if this thread cannot take data from the main thread, like it doesn't really work. So yeah, it really limits the use of workers, so the threads on the web. And at the time of Godot 4.0, like the team thought that it was a solvable issue, and this was just temporary. The shared array buffer is not accessible, was just temporary and will not go away. But we found out like, yeah, like there's no really like, because the issue is like directly based in the CPUs and such, like there's no way to fix it. So the limitation is there to stay. So usually games, you are single threaded on the web. It sucks, but like that's the reality. So we realized that that wasn't the case, and we implemented back in 4.3 the option to run single threaded a game. So where are web games published? Like, that's a good question. Like where can I play web games? You can self-host. Like it's the most obvious thing, but like maybe maybe not that obvious. Like you can really like host yourself a website. It doesn't cost much, and you can put your HTML files there, and you can run your games and share the URL, and people will be able to download your game and play it. You can simply whip up your web server, and it comes with all the bells and whistles that comes with the web platform. That's great because you don't have to pay a license to like some technology, and there's no like server rankings, or like you need to unlock some type of server to be able to serve some type of game. Like the web, your browser, like either it's Chrome, Safari, like or Firefox, like comes with a lot of technologies that are available to you, and you can use them. So it's really like the web is really accessible for anyone that wants to use it. You can I put self-hosted itch.io. I think itch.io is like resembles like self-hosting, because like you can just upload your game, and then usually you can either make your people like pay if you want, or if you want you can put it free, and it resembles like self-hosting without the ability to be accessed to the without being able to access like the server settings and such. But like you can do a lot of things with itch.io. It's often used for game jams, and really like people will play more your game if you put it on the web. That's like you people like really want to like show up your page, play a game, and rate it, rather than like having to download it and such. So if you want to make your game accessible for game jam and such, like publish to the web, it's really a good suggestion. So there's web game platforms. So there are specialized platforms that host multiple games. We can think about Pokey and Crazy Games. Some are very popular and successful, like these two. I have a word from Dennis McEwan from Pokey, and he said to me that last year they had 65 million monthly active users. And this year, we're not even finished the year, but like they're at 90 million active users. That's a lot. So the web, there's a lot of people that wants to play web games. So I really encourage you to like actually like think about the web game, the web platform as a primary platform, perhaps. But like, yeah, it's really a great platform to work on. And there's also a great tip from him about like web games. These I will cite them. So these players are worldwide, which means optimization is really important, like in the size. most importantly. Generally, I would put a bit of focus and importance on making sure that your game is optimized and that there's will need to be uh, and that there will need to be some changes made compared to Steam and mobile. It's a very different platform, which means the UX is very different. So very little text, super fast onboarding. Like you need to put the fastest you can your player into the game and not like have a super long tutorial that blocks the user from playing the game actually. This will impact monetization because players cannot enter the game. They can't play or watch ads, so you need to keep that in mind. So thank you, Dennis, for your tip. And the word got around, so there was like a lot of new players in the there was YouTube that began hosting games. There was the Game Snack that is a little bit older, that targeted like since like 2020 maybe. But there's Netflix that makes web games now. There's Discord activities. You can play web games on Discord with people. And even LinkedIn began hosting games. So as I said, the word got around. So apps, so not only games. So I think what all these technology that I showed you like were very interesting was that the fact that they 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 enable the developers to create apps for the web. So you can you can go to a website and use it as an app instead of like downloading a client or something like that. So web apps are really thriving currently. So there are specialized websites that can do things that normally reserved for desktop apps. One of my favorite web apps are Squoosh. I can show you Squoosh. So imagine that you can drop your files, any files that you want, but like imagine that I have this one. You can really like compress your file as you want, and you see a live result versus the original one. So you can really optimize like the crap of an image to be the size like minimal as possible. And that's great because you can put it in Godot and after that, and you make sure that you export it as is. So it will be using that file directly in your game. And this makes so that it will be super tiny. So especially if you are using that famous WebP is like magical. So just selecting WebP without doing anything, like the quality didn't pretty much change at all, and it's like 90% down. So yeah, it really pays using WebP. So yeah, that's a win for WebP. A few wins. But there's another favorite app of mine. I think the Godot engine editor itself is a web app. So if I click there, like you can start the editor and really like start any project, and it's really the editor itself. Like it's not like a toned down editor or something like that. It's really the editor that we compile for the web, and that's it. So you can like create, it's in French, sorry, but like you can create here like a main node and then create a script, and then you can actually like write code like if you were, and you can export the project afterwards to be able to be ran like by an actual desktop Godot editor, but like is the file that will save, it's the same that the desktop would save. So really, it's really interesting now that we can do this on the web. Like it's literally like, except for the top bar, like you couldn't know that it's on the web. So I'll just close this. Perfect. So next one. State of Godot for the web platform. Like I have like maybe could like reduce the time. So I think I have enough time. I think it's quite good right now. There was a lot of stuff that we did like in the last year, and it made it like Godot 4.0. Like I said, like usually games are hosted single threaded, not only because it's possible to run threads, but it limits you security wise to your own domain. So you cannot download anything else than or show something else that comes from another domain if you're using shared array buffers. So it really limits you. Like you cannot play, like you cannot access, like imagine that you want to add monetization to your app and you want to like to add a Stripe integration or something like that. You cannot. And if you want to play ads, usually they reside to another server, and it's that server that decides which ad will be displayed in your game. You cannot. So really, it's important. Like most of the web platforms that I showed you, like they don't accept games using shared array buffers because like it breaks everything. So really, the single threaded option is really like the mandatory one. It's not mandatory, but like really encouraged. But like since Godot 4.3, like we introduced it, and like it changed the landscape for Godot on the web. Like people used to like they couldn't use Godot 4.0, 4.1, 4.2 because they needed like to use Godot 3 instead to export to the web. So I think like right now, like Godot 4 is like quite apt to publish on the web. But there's a lot of things to do, like to push the engine further. This is the Godot community poll of 2024. There were some questions, and I was a little bit discouraged. But again, I reread the stats, and I think I'm okay with them now. Like, which development platform do you primarily work? Like Godot Web was like 3%. But I was like, oh, primarily. Like recently I was like, oh, it's primarily work. So it's not necessarily like, do you use web or not? So I think 3%, that's great. That 3% of people like use primarily Godot for the web. But I think it could be like, I encourage you to maybe try the web and such that we can like push this number like further up. It could be very interesting, I think, for everyone. So there was other stats like what are your main export platform, and I was really astonished when I saw that. Like it's 38%, like 39%. That's a lot. So yeah, that's great. I think like people actually use like the web, even if it's not the primary platform. Like they actually use the platform for publishing. And the state of Godot, like about like main revenue sources, it's really interesting because like if you add Pokey and the web, like it's nearly 15% of people that live from like the web. And itch.io, I don't know, like it's itch.io, so we didn't specify like itch.io like for the platform that you're making from itch.io, but like yeah, like maybe a small percentage of itch.io is a web game, is related to web games. So yeah. So state of Godot web features, what is currently possible? So I think there's full Godot compatibility with a star. Single-threaded export, web audio samples, GD extension support, that's really, really important. And what's on the radar? There's web GPU, web transport, and .NET C#. So what is currently possible? So full Godot compatibility with an asterisk. So nearly every feature is supported. As I showed you, the editor runs, and you can create a game from within the web editor. But as much as we can make it work with the web platform quirks. Like there are some things like, imagine that just pasting or copy paste from a web page, if a third party wants to access it, it must come from an action of the user. So usually in the desktop environment, you could like, whenever you want, you can just like copy paste. It could be like upon a timer, and then you get the clipboard contents, and then you do something with it. But on the web, you need a user action to actually trigger the action. So yeah, when you're exporting to web, you need to know about these quirks. You need to know like about the security. Like it's for security and such, but like it can be an hassle. But like yeah, make sure to know about the web like quirks. But usually you can do a lot with web exporting. Like just exporting in game, it should work pretty much as is. It's even compatible with XR via WebXR. So my friend David Snopik works really hard about like WebXR compatibility. David is there, so we can thank him for this. So I highly encourage you to tune in for the What's New in XR and Android talk at 2:30 p.m. Later. Single-threaded exports, I think I told you about this. It's available for SYN 4.3. See the web limitation slide. And yeah, the issues it introduced, because when I introduced single-threaded builds, it introduced some issues about audio, and then it made it so that we introduced like web audio samples, and oh, the S is decided to get away. So it's a new feature since 4.3. It's the sole way to offload audio. As I said, it's single-threaded, but currently how Godot handles streams is that they handle it by itself by spawning usually a new thread, and then the audio is getting processed in that thread, like on the desktop and mobile and such. But on the web, we cannot spawn a new thread. So there was like a lot of glitchy audio when using like streams and user streams. So I introduced like a new way to handle like web audio. It's by default, it uses samples when you export to the web. If you want streams to have specifically like the specific things about streams, you can set it in your options of your audio player. But like, yeah, currently it's quite equivalent of having a user thread, but like it's managed by the browser. So you can just like, we just have to spawn, tell the browser, hey, play that sound, please. And it works. So it works very well. There's no latency. So if you want to play a sound, it sounds like really, it starts like as you wish on time. But the cons is it doesn't support every feature, such as like audio bus effects. I'll try to maybe someday, if there's demand, maybe add a way to patch it and to have audio effects. There is a way to make audio effects with a web audio API, but it requires like some code gymnastics. So for yet, it's not yet implemented, but I look forward to make it work. GD extension support, as I said, super important. It's possible to build native libraries for the web. There are some caveats though. You need to build your GD extension with the same version of scripting that was built, that built the template, because API-wise, ABI-wise, they need to be talk to talk the same language, so the same version, because it changes every version. So there's that. D-Link must be enabled when you export your template, and thread support must match the exported template. So if you're like, usually you should like compile your GD extension to be running single threaded, but like it can change your logic of your extension and such. So be aware. What is on the radar? So there's web transport. Web transport is a follow-up of the WebSocket API. I'll go a little bit faster. There's a lot of things to do and the time flies by. So it introduces the concept of unreliable transports. It's similar to UDP. What is UDP to TCP? So faster latency and such. Web GPU, I'll skip through it because there's a lot of things that I want to talk about with GPU, but like, yeah, it's an upcoming rendering API for the web. It's like the, you can compare it to like Vulkan, Metal, or DirectX 12. It really enables you to like talk to the GPU directly. There's a demo. I will not show the demo, unfortunately. It really like, the demo would show like that it really looks nice. The difference is, I met with David Zong, is a UCLA student in computer science and engineering. He started to implement web GPU in Godot. It was really nice. I'll skip to, this prototype looks like this, but it rendered, so it's like an hello world for Godot and web GPU. It did not try to target any browser, but so I asked him like what he got from his test. He says that Godot rendering pipeline is very good. That the overall problem stemmed from the features that aren't supported yet by web GPU. So there's some issues that we need to work on. But those features will be either patched, or we can do something about them, or they will come to web GPU. So maybe web GPU is not yet primed to be integrated in Godot, but like there's work that can be done towards it. So yeah, I skipped the. What to expect from web GPU? The mobile renderer should be available when you export to the web if web GPU is enabled. The current state, the limits of the browsers and such are too low for now to enable Forward Plus, but that's pretty much what it would enable you if we ever support web GPU, is that you couldn't like use the mobile renderer instead of like the compatibility one. That is the default, because the compatibility one targets WebGL. That is the technology that resembles OpenGL for the web. And you could be able to use compute shaders on the web. That's really nice. The .NET on C# on the web, it's a complex, very, very, very complex topic. We tried to make it work a lot. We used .NET.js. There was a technique, we didn't work. Native AOT LLVM didn't work. And we tried statically linked mono, didn't work either. So we really promise that we get back to you as soon as possible when something changes. Oh, what's this? April 23. It's a message that I received from Raul Santos. I've been working recently on web exports for C# again, and I think I may be able to make it work. So let's ask you. You can open up right now lab.godotengine.org/godot.net web, and there will be a demo for Godot.net. You can see here it's you cannot see here right now. It's because it's on the other screen. Sorry. I click here. It loads its Godot, and you can have like a code editor here, and it says right line. And if I hello GodotCon and I play, it prints. So yeah, that's working C# with Godot on the web. If I go, oh, I need to handle this, please. Okay. Then there, I can access back. No, I closed my window. Oh no. That will it? No, no, not that. Okay, so I will reduce directly my slides then. So sorry for the little setback. Okay, so I will go blind. So we finally used linking statically. Ono did the trick using stubs. I had like a text of how he did it, but technically we use stubs to like temporarily like have pointers that point to the right functions. And when you export, we export the list of functions. Well, super complicated. There will be a blog post about this that will announce like our prototype. So keep an eye on it, but like there will be the full explanation on that and there. It's a prototype. It's not the export template yet. There's much work to be done, but like it's great news, I think, for the C# and .NET community. So here's the prototype. The draft pull request will be incoming in a few minutes, and there will be the demo also available. And there's a lot, yeah, that I said. So what's next? I think what's next for the web will take like maybe 5 minutes to talk about this. Like I will skip through. Tackling load times. I think why improving load times? Because users are impatient, and players should be able to play as fast as possible. Like you should be able to whip up your phone and like go to a website and then play, and not like wait too much time on the screen. So there's rewrite the JavaScript glue code. I think it could be improved, but like it's more for the developer experience more than anything else. I put it there because that's a wish that I have. I propose, that's my proposal. It's not official, but like I really want to make sure that it's communicated that way. But like it's the idea of an async loader. So currently, the old problem with Godot is that we currently the PCK, like there's no way to split it easily, and then that makes the PCK contains the whole game. So even if you and your boss fight at the end like is loaded even before the player can play start, so can press start. So like yeah, that's okay for a desktop platform, but for web that's not really great. So what if there could be a way to load on demand assets for Godot? So my idea would be to have an async loader node, and that node you drop it to the scene, then you tell the dependencies of what you want to load next. Then you set up the signal like when it's ready, and you declare you declare what you need next, and then you trigger start on the node itself, and then the node will ask the OS to download it. So for the web, what it means is that we delegate the downloading to a fetch request, an async one, that makes it so that it's not the actual code of Godot that downloads it. So it make less sense like to load something from OS to your game on desktop, but like it will make sense for the web. So there will new methods that will require the OS to download the file, and that makes it asynchronous. And when the files are ready, the loaded signal will be triggered, and you'll be able to say next, trigger the next scene, and then the scenes should be able to load when you type load and the parameters of your like the path of your asset. So that's the idea behind it. So I think it could solve the issue of loading everything all at once. And it could help, like maybe like for consoles and such, which want to like show the gamer like as fast as possible, like a screen, and loading the entire PCK isn't maybe the ways to do so. So maybe it could help on other platforms too, that node. Optimizing the engine size. Currently, there's a blog post that was made by Popcar titled "How to Minify Godot Build Size from 93 megabytes to 6.4." That's the desktop size. The real size for Godot usually on web is 45, but like yeah. So I really encourage you to go to the blog post. But like it got me thinking about like what could be done by the engine itself to like save space. And we cannot really strip features because what it does a lot is that, oh, I don't need like 3D, so I'll just remove 3D from the template. But like usually when you download the official templates, you want to be able to do everything. You don't want to like to game your to crash because it accesses 3D and the template doesn't support it. So yeah. And what's left is compression and running wasm opt. That is a command. So thank you, Microsoft, for the like. I'm in the Microsoft office. It's from the Xbox. I think from Xbox presentations. And I'm introducing built-in pre-compression. So what it does is a lot of HTTP servers, like I showed you before, when you request the HTTP server, like you can tell the server that you accept some encodings, and the server will tell you which encoding it's used. So instead of serving the raw file, that is like for the WASM for Godot is like 45 megs. Like instead of serving you the 45 megs, it can serve you instead like a smaller file. But it takes some time to compress. So what servers do usually accept is that if you have your index.wasm file, I think I have the images. Yes, a non-configured server will you ask index.wasm and tell them that tell the server that you accept BR compression, and the server like is not configured, so it will return you index wasm. You ask for it, so that's what it will return. So with encoding, like it will tell you that there's no encoding with the file. But with a configure server, you can ask for index wasm, but access BR. And then the server will say, oh, I have an index wasm BR file. So I will serve that instead of the index wasm. I will serve it as index wasm, but tell the user that the browser that it's encoded BR. So that makes it so that like the difference between index wasm and index wasm BR is like 4.5 megabytes instead of like 45 megabytes. It's like 10x. Like that's a lot. So the idea will be to introduce built-in pre-compression. So it's an upcoming PR. Like I will release this PR like as soon as possible in the next days. So that will add new features for template developers and engine users. What it means is that there will be a new compression option for the web platform. Like when you do scans platform web, the target template debug, when you build yourself the engine, you'll be able to say compress for servers and tell which compression you want. By default, it will be none or all. Like you can literally like tell the build file like which compression format you want to compress to. And after merge, like what I want to is that every template file that you download to export will include those files by default, compressed. So it will like make your template files larger, but when it comes to the server itself, when the user will download it, what the user will download, it will be very different. So new options to the web export menu will add like bandwidth saver, like ZSTD compress, gzip pre-compress, and like broadly pre-compress. It's like all different formats. You can search it online what they do. But like you could like when exporting, it will like compress what is not compressed already. So it will compress your index.pck. Like it will compress other files. It could take some time, especially broadly. I added a warning. Broadly is really takes a long time to compress, but it's the most efficient one. So you have to like see how it goes. But now everything relies on the HTTP server to actually like handle that choice. Okay, so I'm introducing a decompression fallback system. So what it does, it will add on-demand JavaScript modules that contain native CSTD and broadly decompression utilities. So what it will do is that when you download a file, the download script will see, oh, okay, so the file isn't broadly compressed or isn't compressed at all. It will ask the server if the compressed file exists. If it does, it will download it instead and decompress it on the fly to use the decompressed version. So what it does is that means that you, the users, don't have to do anything to reap the benefits of compression. So I think it will change the game on how we distribute web games for Godot. Like, it's really free for everyone, the benefits of it. So I'm really, really happy for that. Short time, but I don't think I have time. It's like 10:58. So I really, really thank you all. And if you ask questions, don't hesitate to ask me. Thank you.